All right, welcome back. So, for anybody playing along at home, again, here's the warm-up. Quiet, please, folks. Yeah, let's stop eating the frosting. That's Jack Brophy for anybody watching at home. That's the one I'm having to tell them. Stop eating frosting in a math class. Things I thought I'd never say in a math class. Stop eating the frosting. Okay. So here's the warm-up again. These 4 problems. So let's go over those. Now, I think you can see that if I were to solve our first one here, 19, we've got 5x plus 3y equals 30. Oh, hold on. I have to unplug the plug. 5x plus 3y equals 30. Remember that I can go straight away to say 5x equals 30, so x equals 6. 6 comma 0. Positive 6 comma 0. And then I can go straight away to say 3y is equal to 30. Why can I do that? Why can I just block out those other terms and solve? What's allowing me to do that? Good, yes. Good. And what form was it presented to me in? What was that? Standard form, right. Standard form. Because this was presented to me in standard form, I can say, okay, 5x equals 30, 3y equals 30. Let's finish it off. Y equals 10. 0, comma 10. Now, I will tell you that every one of these intercepts are either positive or negative, 6 or 10. So, 19 is positives and positives, which is graph A. 20, they're both going to be negative because whether I divide by positive 5 or positive 3, those are both going to give me negative outcomes. So negative, negative, okay, that's graph C. Number 21, if I divide by positive 5x, I get positive 6 as my x-intercept. So positive 6. If I divide by negative 3, I get a negative 10, so negative 10. Graph D, that must mean graph B is my last one. Negative x value, positive y value, negative x, positive y. Questions on the warm-up? Okay. Give me at least one to go over from 10 through 16.
24.
Give me at least one to go. Let me repeat myself. Give me at least one to go over from 10 through 16.
16.
Thank you.
24.
24. We know math. A number between 10 and 16, 24. All right. So let me bring this to a new page real quick. Quiet, please. Quiet, please. Again, everything you say is being recorded. I know, really. 3x plus 5 is equal to y. So I plug in 0 for y and I solve for x. That means I have 3x plus 5 is equal to 0. Quiet, please. So 3x plus 5 is equal to 0. I subtract the 5. Divide by 3. Now, in this case, when I divide by 3, I can leave it as a decimal. If you want to leave it as negative 5/3, that's totally fine. But that's negative 1 2/3, or negative 1.6 repeating. Negative 1.67. Or, as a coordinate, negative 1.67, comma, 0. Well, that is written really well. Now, when I go to find my y-intercept, well, that one's a lot easier because it would be 3 times 0 plus 5 is equal to y. The 3 times 0 goes away, so 5 is equal to y. Or in other words, 0, comma 5. Let's get a graph real quick. I can use my 6x6 graph. All right. Okay. I graph my y-intercept and my x-intercept. I'll put my x-intercept in blue, negative 1.67. My y-intercept is 0, comma 5. And I graph my line. Whoa. Hopefully you hit the points better than I did. Questions on that? I'll tell you right now, we just made the quiz for these next two sections. Again, the quiz is going to be next Thursday. We're going to be spending 3 days on section 3.6, Thursday, Friday, Monday. Review Tuesday, quiz next Wednesday. Everything will fit on the graphs that I give you. So if you're doing a problem and you're like, man, they gave me a 6x6 graph and I got my intercept to be like 12. Something's wrong. Okay. Questions on other parts of the homework? I'm sorry, just 10 to 16. Okay, let's go over one of the ones, 23 or 24. Which one do we think?
24. Both. 24.
24.
Let's do both. Why not? All right, so let's take a look at 23. 23. You have a budget of $300 to order shirts for the math club. Hey, that's my kind of club. We've got short sleeve shirts and long sleeve shirts. We have $10 is the cost of the long short sleeve shirt and $12 is the cost of the long sleeve. So 10 is short sleeve, 12 is long sleeve. All right. So if I want to find here's my equation, 10x plus 12y is equal to 300. We set 0 in for y. So we say 10x is equal to 300. And when we divide by 10, obviously that is 30. 30 comma 0. All right. I put it over here because that's part A. Interpret the coefficients and terms. Oh, it says interpret the terms and coefficients. I kind of did that already. $10 for the short sleeve shirts, $12 for the long sleeve shirts. But anyway, sorry, kind of glazed over that. 12y is equal to 300. We're still solving for the intercepts here. We divide by 12. So y is equal to 300 divided by 12. 25. So 0 comma 25. Can somebody tell me what my x-intercept 30 comma 0 represents? What is my interpretation of that? Will equal what? $300, right? $300. So 30 short sleeve and no long sleeve is $300. In the other extreme, 25 long sleeve. Oh gosh. Let's sneeze. Oh, and I said it. No, I'm not going to sneeze. 25 is long sleeve and no short sleeve is $300. That's the interpretation. Okay, let's find the graph now. Let me pull this graph over. Well, that's large. Okay, so the x-axis is short sleeve shirts. The y-axis long sleeve shirts. We have to go to 30 on the x-axis and 25 on the y-axis. Let's go by fives. 5, 10, 15. No, that's way too small. Let's make each box. Let's go 5, 10, 15, 20. That's 25, 30, 35. Yeah, let's do that. 5, 10, 15, 20, 25, 30. Okay. Okay. Again, you're drawing it on graph paper, so you can kind of make the scale whatever you want. But just make it even. Make it a nice and even scale. My blue is, what was it, 30? My red is 25. And I graph the line in between them. I'm going to use my fancy line tool. Okay. All right, so that is my that's my graph. It then says to find 3 possible solutions in the context of the problem. Did anybody find a solution? I think I gave one on the key. Which one did I give on the key? What did it say? I don't remember offhand. Addie?
I said 18 short, 10 long.
18 short, 10 long. How would I have checked that if that was truly a solution? How would I have checked that? How would I have checked if that was a solution? Plug it in. So 10x plus 12y is equal to 300. 10 times 18 plus 12 times 10. Whoa. 10 times 18, close parenthesis, plus 12 times 10. $300. So I know that is a solution. Okay, questions on that one? No? Anybody still need anything there? Okay. Clear ink from page and delete this big white box that I made. Okay. And so long, Lauren. Okay, we're jogging and biking. We want to go a total of 150 miles. So 150, 12.5x plus 6y is equal to 150. Okay, the terms and coefficients. What is the 12.5 representing? Well, the x value represents the number of hours I bike. So that must mean I'm biking 12 and a half miles per hour. The 6y, the y represents the number of hours you jog. So that must mean I am jogging 6 miles per hour. Obviously, I'm going to bike faster than I jog. Now, part B says interpret the intercepts and graph the equation. So 12.5x is equal to 150. So I divide by the 12.5. So x is equal to 150 divided by 12.5, which is 12. So 12 comma 0. I do the exact same thing for y, but I say 6y is 150. So divide by 6. 150 divided by 6 is 25. So 0 comma 25. Now, what's the interpretation of those two intercepts? Okay, 12 comma 0. Remember, the one extreme, all of one and none of the other. 12 hours of biking and no hours of jogging will give me to 350 miles. That's the interpretation for my x-intercept. What's the interpretation of my y-intercept then? Well, 25 hours of jogging and no hours of biking. If I only jogged, it would take 25 hours to reach my 150 miles total. Okay. So now I go to graph that. Let's go. My x is biked, jogged, and this is hours of those things. And then we have, 12. I think I could go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll write that in there. And then I have to go up to 25, so I can't just go by ones. Let's go 2, 4. Nope, that's the same as one by ones. Can I go by twos? 2, 4, 6, 8, 10, 12. I think I can. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So My red intercept is going to go right there. My blue intercept is going to go down there. And I graph my line in between them like so. There's my line. Now, the last question says, you bike for 9 hours this month. How many hours must you jog to reach your goal? Okay. How many hours must you jog to reach your goal? Well, that's like saying 12.5 times, remember, bike is x, 9 plus 6y is equal to 150. Okay. All right, so all I have to do is solve that equation. 12.5 times 9 times 9 gets us 112.5. 112.5 plus 6y is equal to 150. I subtract the 112.5, and that gets me 150 minus 112.5, 37.5, I think. Yep. And I divide by 6, and that gets me 6.25. 6.25 hours jog. Now, I am really happy if you got there. The rest of it, you're just plugging in the other two values, like saying, okay, if I really do bike for 9 hours, I'm biking 112.5 miles. And then I would just take this 6.25 and multiply it by 6, which gives us 37.5 miles. Okay. All right, let's get to our guided notes for today. Okay, so here's the day we start talking about slope-intercept form. Well, at least that's the section. If I ask you about slope-intercept form, I'm pretty sure you guys can tell me y equals mx plus b. I mean, that's like, I would be surprised if you got out of 8th grade math without knowing slope-intercept form. Y equals mx plus b. No, we're not watching slope, dude.
You don't know what slope duty? Yeah.
Algebra 1.
You know that video? You didn't watch that video? I wouldn't realize.
Okay. Now, what we're going to talk about in this section is slope-intercept form. We're actually not even going to talk about slope-intercept form today, because to understand, bless you, my sneeze got it, transfer me apparently. To understand slope-intercept, you must first understand what slope is, right? To understand slope-intercept form of a line, you must first understand what slope is. So that's what we're going to do today. We're going to spend a day to talk about slope. Now, what is slope? What is slope? I know you guys probably remember a lot about slope, probably remember how to find it, maybe remember the equation. But here, in a nutshell, slope is a numerical representation of the steepness of a line. Okay? If I had to define slope, it's a number that represents the steepness of a line. The bigger the number, the steeper the line. The smaller the number, the more shallow the line. Okay? So, bigger the number, steeper the slope. Slope, in general, can be represented in a variety of different ways. You can talk about it as rate of change. You could talk about it as change in y over change in x. You could talk about it in terms of the equation, which you see on the board there. Again, if you don't know this thing, you better star it, circle it, highlight it, do whatever you need to do. y2 minus y1 over x2 minus x1. You guys should be happy that you don't have me as a geometry teacher. I made my kids, when I taught geometry, I made my students like write out theorems and formulas and all that stuff. I made them write them out like for memorization. Like on top of homework, there was like okay, write this 20 times. Like, you guys want to do that? You guys want to write the slope formula 20 times today?
Yeah, all the way.
Yeah, kind of. No, that won't work.
I've gotten soft in my old age. We'll just bear with it. But anyway, that's a formula that you need to commit to memory. That's a formula that you need to commit to memory. y2 minus y1 over x2 minus x1. Somebody said to me, well, we learned it as x over y last year. No, you just remember it incorrectly. It is y2 minus y1 over x2 minus x1. Change in y divided by change in x. It's the rise divided by the run. If you're a science person, you might see it written as this. Delta y over delta x. All that is just a symbol to say change in. That's delta, Greek letter. All right. Oh, one last thing about slope. We could either have a positive slope or a negative slope. When a line is going up and to the right, it's a positive slope. When it's going down and to the right, it's a negative slope. You want to know the really easy way to tell if something is a positive or a negative slope? I'm going to blow your minds here. A negative sloping line will always make the crossbar of an N for negative. Crazy.
Oh yeah, I get the right side of the W.
But why would? But N stands for negative. Somebody was like, "Oh, well, then it could make a P." I was like, "Sure, but technically, so could the other one, But that's not good. Don't remember that." So. But what if you're ever looking? A negatively sloping line will make the crossbar of an N. It's okay. I got you right there. That was not Addie, if anybody's watching at home. All right. So let's take a look at our first example here. I'm going to give you 3 different representations of lines. One given one time we're going to give you a graph. We're going to give you coordinates. And then we're going to give you a table. And each one of those I'm going to ask you to find the slope. So let's start with a graph. Now, when I'm given a graph, I want to pick out some nice points. What do I mean by nice points? Ones that are smiling at you. No, ones that cross nicely at given values. Like, I don't want to pick 1.5 comma 0 or like 1.5 comma 2.2 or something like that. No, I don't want to do that. I want to pick ones that are crossing nicely at even values. Now, when you're given a graph, literally, folks, all you have to do is just count the boxes. Count them up. Count them over. So, what's my rise? 3. Again, not adding. The slope is rise 3, run how many? 1. Is this a positive or negatively sloping line? Positive slope. So I can just say m is positive 3. If you want to leave it as 3 over 1, that's actually okay. I'll say in the next one you've got to reduce all your fractions, but 3 over 1 is kind of like a reduced fraction. So now, did I need to just choose those 2 points? No, I could have chosen rise 3, run 1. I could have chosen rise 3, run 1. Or I could have gone all the way. I could have chosen rise all the way here, run all the way there. Would I have still gotten the same slope?
Yes.
Yes, because this would have been rise 9, run 3. What's 9 divided by 3? 3. That's what it means to have a consistent slope, to be a linear equation. Let's do that again. Let's pick some good points, pick some nice points. Looks like it crosses nicely those 3 times. Now, we know that this slope is what? Positive or negative? Can we draw an N? Yes. That's okay. So we can't, please, people, please, stop talking. We can draw an N, so we know that the slope is going to be negative. And now, let's figure out what that slope actually is. Let's go from here to here. Rise 1, run 3. Rise 1, run 3. -1 third. There's my slope. It's pretty easy when you're given a graph, right? Did I need to just pick those 2 points? No, I could have gone all the way. I could have gone from here to here. Rise 2, run 6. But 2 6 would have reduced down to 1/3. Always reduce your fractions. Same thing here. Last one of these. Pick some nice points. Looks like my y-intercept is nice. Looks like there's a point down here and a point up there. Okay. Let's stop with that. Thank you. Let's pay attention, Gavin. We're going down to over that much. Down to over 5. 2 over 5. Is this a positive or negatively sloping line? Negative. So I say it's -2/5. See, I don't have to worry about whether I'm going up or down or left or right if I just remember to tack on the correct sign in the end. If it's going down and to the right, then it's negative. If it's going up and to the right, then it's positive. Okay, a couple more graphs. Now, when you have a vertical line like this, how much am I rising? 1, 2, 3, 4, 5, 6. How much am I running? 0. I'm running 0. Okay. What is 6 divided by 0? Not 0. Not 6.
Can't do it.
Can't do it. That's another way to say it's undefined. It's undefined. You cannot take a number divided by 0. It is undefined. So therefore the slope is undefined. Whenever you have a vertical line, the slope is undefined. Some people say, consider this no slope. I don't like that. I like the slope is undefined. Okay? Take a look at this horizontal line. Well, the slope here, each box is going by 2, so it's 2, 4, 6, 8, 10, 12. There is, sorry, I did run over rise. Is there an amount of rise? No, the rise is 0, but the run is 12. Well, what's 0 divided by 12? That is 0. That is 0. My slope here is 0. Okay? So any vertical line is going to be an undefined slope, where any horizontal line is going to be a 0 slope. Okay, let's take a look at the slope formula. Now the slope formula, we looked at on the very first slide. The slope formula is y2 minus y1 over x2 minus x1. What's that mean? I'm going to take the second term, the second coordinate, and then subtract away the first. 1 minus 5 over 8 minus 2. 1 minus 5 over 8 minus 2. -4 over 6. Am I allowed to leave the slope as -4, 6? No. You must reduce it down. Anytime you give me a slope, the slope must be in a fully reduced fraction. 2/3. Every time I ask you to do the slope formula tonight, if I give you two coordinates, write out the formula. You have to write out the formula. So let's do it a couple more times. Let's take a look at example B here. M is y2 minus y1 over x2 minus x1. y2 minus y1. -4 minus -7 divided by 6 minus 5. Okay, -4 minus -7. That's +3. Because it would be -4 plus 7. 6 minus 5 is 1. Okay, the slope is just 3. Again, if you wanted to leave it as a 3/1, that's completely fine. Okay, flip it over on the back. Now, take a look here. My two coordinates left here are special cases. Let me show you. y2 minus y1. -2 minus -2 over 7 minus -2. See, alarms are flashing, red lights are flashing in my head because -2 minus -2. What is -2 minus -2? 0. 0 over 9. So my slope is 0. What does that mean about my line? It's a horizontal line. It is a horizontal line. The slope is 0. It is a horizontal line. In contrast to that, -6 minus -3, -5 minus -5. Okay, now where's the 0? In the bottom. So this is -3 over 0, which makes the slope what? Undefined. What does that tell me about my line of those 2 points? Vertical. Last type of problem. So we were given a graph, given 2 points. What about given a table? Guys, we've done this before. We did this when we were asked if it was linear or not. We just didn't really call it the slope. +3, +3, +3. -6, -6, -6. That's the linear test, but what's my slope then? What's the slope then? Change in y divided by change in x. -6 divided by +3, or -2. See, when you have a table, all you need to do is look at that change in y and change in x to see whether what the slope's going to be, and then you divide the change in y divided by the change in x. Take a look at this next one. Look at my change in y. Am I changing in the y values at all? No, so my change in y is 0 over doesn't matter. What's 0 divided by anything? 0. The slope is 0 for the next one. Because my y values do not change. There is no change in y. In contrast to that, now I see that there's no change in my x values. So this is something, I don't even need to look at my y values, divided by 0, which makes the slope what? Undefined. The last graphic that you see on your guided notes is just a, kind of like a summary of everything that we talked about, the 4 different types of slopes. Because on the homework tonight, it's going to ask you to identify the slope, then find it. So whether it's positive or negative, 0 or undefined, then find it. Okay? Perfect time. Bell's going to ring like a second. So long, everybody at home.
Bye.
Have a great one. Now I ate my frosting.